Going with our next set of panelists. And again, another one of our keynote and panel sponsors. I get to bring TACG up here again, so we get to hear from Mr. Keith Harvey again to tell us what we're going to be talking about.
Good morning again. I think it's still morning. Here I am again, Keith Harvey, TACG, Director of Business Development, and an FCA member. Don't forget that. Got to put the plug in for FCA. So we got a great panel coming up. They're standing to my right, and before I introduce them and bring them up here, I'll like to go over TACG just one more time. I appreciate you being patient with me, but I would like to talk about TACG more in detail. I talked to you about earlier about us being part of the Copper River family of companies. TACG itself is one of the operating companies, runs as an operational company on its own, though we can leverage and do leverage our sister companies' past performance and vice versa, and our strength together. So together, in the synergy we provide, we can deliver about any capability out there or deliver any solution that's needed. TACG has a long history here in Dayton. I mentioned we were founded in 2006, and we're acquired in 2012 as part of the Copper River family. But our roots are here, as I mentioned. Wright Pat has been a long-time customer. We're proud of serving the U.S. Air Force. Our customer base has expanded over the years. Since I came on board in 2010, it was all Air Force. And today we have over 150 employees, CONUS and OCONUS, that is international and continental U.S., in places like Saudi Arabia, UK, and Japan. So it's been very, very cool to see the company grow up and mature over the years and be a part of that success story and that journey. So it's been very, very exciting. We provide a wide range of services, including logistics and supply chain management. And that's really where we started, was here at Wright Pat AFMC, in particular AFMC A4, and now LCMC, as well as AFSC, and some AFRL work. So we're very proud of that history and legacy and serving our country as a defense contractor. Another area has been digital transformation. We understand that digital services help transform Air Force operations, stay ahead of the potential adversaries. We're hearing that every day, right? The different adversaries out there and how the landscape has changed over the years and the decades. And how its digital transformation is able to transform the mission and bring forth cutting-edge technology or technological solutions. We also provide cybersecurity, zero trust, RMF as well, program advisory services, and foreign military sales, which I've mentioned previously with Saudi Arabia. So very broad-based. Here at home at Wright Pat and Dayton, data migration, data integrity work on some of the Air Force weapon systems. We're doing that today and delivering those data solutions to the U.S. Air Force. So I'm proud to be here today and represent TACG and appreciate the opportunity to talk today twice. So that's been fantastic. Now, so moving on, I'd like to say that it's my pleasure to introduce the moderator of today's Structure and Secure Data panel, Dr. Mike Schneider. He is with AFLCMC, Intelligence, Surveillance, and Reconnaissance and Special Operations Forces Directorate. and he is our human autonomy teaming technical expert. So Dr. Snyder, it's all yours, sir. Thank you very much.
Good morning. Like you said, I'm Dr. Mike Schneider, call sign Frood. I'm the Human AI Teaming Tech Expert up at the Medium Altitude UAS Program Office. Previously, I've done a lot of work on digital engineering and how we structure and secure our data so that we can understand what we have access to. We got a great panel for you today. We have Mark from the Engineering Home Office Configuration Management Directorate, or branch. He is an engineering data SME. We've got Mr. Randy from Siemens. He is a fellow, going to talk to us a lot about what Siemens Team Center has to offer and how that works with Air Force PLM and supports that. And then we have Samantha, who's a distinguished data scientist at UDRI. Did I get that right?
Yes.
Excellent. So to kick this off, I'm going to have the panelists kind of go one at a time and give a little bit of a bio, and then talk about how is your organization addressing the data standards, formats, and reference architectures to support development and acquisition activities, either inside or outside our government. What kind of things have actually been deployed and how have they made an impact to the development organizations? Again, this isn't necessarily just inside the Air Force. This could be across industry as well. And then what are the next steps that you see for the future of structuring and securing our data? Mark?
Good afternoon, Mark Spiegel. As Dr. Schneider mentioned, I'm at the home office for AFL-CMC EZSC. I joined there April this year as the engineering data management SME. Previous to that, I worked at F-15 program office as a configuration data manager. Spent 4 years there as CM for the F-15EX program, where we rolled out AFPLM as the pathfinder for that effort. Prior to that was non-government. I've spent 12 years with ATK here in Dayton between manufacturing and quality assurance.
Morning. Randy Langmead. They used to call me a PLM fellow, and I was a digital fellow at Siemens. My background includes call sign Oz. I was a pilot in the Navy, did O-level maintenance, did aircraft division, quality assurance, maintenance department head, was a test manager at Navier for all the PEOA programs, test programs. I've been with Siemens for a while now, helping roll out the software at the Air Force, at the Navy, at our OEM, so I have this broad responsibility across the whole aerospace, defense, federal marine group.
All right, good morning. Samantha Aduccio. I love the fact that he skipped my last name because people are like, my husband says, well, if you can pronounce Pinocchio, then you can spell, and there's a ton of echo. All right, is that better? There's a ton, if you can spell or you can say Pinocchio, you can spell or say Aduccio, and I told him I did not know how to spell Pinocchio, so, you know, a year of marriage will get you there. I am a distinguished data systems architect at the University of Dayton Research Institute. I've been with UDRI since June, so I'm pretty new. And I will give you a little background on what they've kind of been up to and what they've been supporting. Prior to that, I was at the National Air and Space Intelligence Center, NASIC, for about 14 years, various roles. My last role there, I was the Chief Technology Officer. Left for family reasons to get a little closer to my kids and get some academia background. So, but UDRI, they have been supporting the SPOs across the board, working with the RSO on how do we get tech transitioned. What does that mean? A little bit on the tactical comm side. I have 22 years of tactical comm experience. I was a combat comm officer, retired in December of 21. And then they're also doing some work with support equipment vehicles is really where they're doing much of their digital transformation sort of work is there, where they're getting after reference architectures. How do you share data? How do you actually do integration, interoperability with Team Center down to the suppliers, and how does that relationship work? And we'll talk a little bit about that later. Thank you.
So, Mark, when we think about digital transformation, it's a shift in the kind of data we're asking to receive from our industry counterparts. What is AFMC or AFL-CMC doing to make that shift happen?
Starting off, we are rolling out the AFPLM, which is going to be our tool that's going to house that data on our authoritative source. We are currently in development of that and assisting that at every level. Data management module has been deployed and is being utilized by one program, the F15EX, along with a few others. Along with the development of that PLM system and that data model, we have created a new DID for our engineering data and associated lists, as we call it the EDAL. That just underwent a major revision, which should be released in Assist this week. What we incorporated there was we removed the use of independent Air Force specifications. The previous engineering data did allowed for content and format to be at the contractor's discretion, which again caused a lot of issues, and going into a digital environment would cause even more. So now we have defined that content and format based on industry standards. And that's really our starting point as we go and define this data model and architecture that we're going to use throughout the Air Force. So we know that this isn't a perfect DID, and it will need to be improved upon as time goes on and we grow and adapt and transform. But this will level set us in a strict format that everyone will be adhering to.
Okay. Mark, Randy. So the Air Force is changing how they ask for data and what data they ask for. Once they get it, what are we doing with that data to make it accessible for all functionals and stakeholders?
It's all part of the whole digital transformation ecosystem, as the last speaker talked about it being accelerating. I mean, we spend a lot of time getting data under configuration. How do we connect that data and put it over? The next step in that maturity is really connection and bringing that connected data together. And that's really where most of the OEMs are, is building huge connections between their data. And in order to really take full advantage of it, you need to bring the data and its connections, all the artifacts together. Don't just take a drawing. A drawing derives from a CAD model, which is driven from requirements. Get them all, keep the connections together, because that really takes you to the next spot where we can go and start automating those and being able to take those rules and those connections and having people, the machine assist us in making discovery, to look through structured data, unstructured data, make those relationships, and then you can have an assistant that helps with the workforce on the generative, and eventually get to the point where I can actually build a closed loop system so that I can connect the digital twin to the physical assets. But as far as getting the data, it's how do I get the bundle from the OEM in context, all the data and the structure at one point into the Air Force. And that's part of our move between the OEMs and the government now.
Excellent, thank you. Samantha, from your experience in NASIC and now at UDRI, there's data, and then that accumulates into information. So what does that layer cake look like for both producers and consumers, and how do we secure it effectively?
Yeah, that's and just for a shout out, so there's a NASIC table in the back. I asked them to come as I was not a government employee anymore, nor working for NASIC, so I want to make sure I had their support. And NSIC's on this side, so both polars. So layer cake. Layer cake really starts in, I feel like I'm really, really loud. The layer cake starts with the bottom, right? We have infrastructure. We talk about multi-cloud, we talk about federated cloud, we talk about agnostic cloud, and that lower level, it starts there, right? So you put all the pieces in that. They're all individual. We have AWS, we have Google, we have on-premise clouds, we have different labs, and they're in that lower IaaS layer. You stick a platform layer on top of it. We have been we don't dictate things very often, but we dictated Kubernetes, right, to manage our orchestration layer of how do we handle our resources. If you drop containers on it, how are those orchestrated? How do you allow access to data across that framework? That piece, it acts as a little bit of an insulator between if I'm running on a Google or I'm running on an AWS or I'm running on premise, being able to say, am I Kubernetes compatible? Can my container run there? If it can run there, it can run pretty much anywhere. It can run on a laptop, it can run on a computer, it can run standalone, depending on what it needs for ins and outs, I guess, probably a better way of putting it. Then there's a data layer that sits on top of that, which is where your data assets sit. And we tend to think about our data all has to be in one place. And for a very long time, that's what we tried to do. We built data lakes and data oceans. I think data lakes and data oceans are still things, just data is separated, right? John and Jack own data, or different suppliers. If we look at support equipment vehicles, there are, I don't know, a lot. I don't remember the number they gave me, thousands of suppliers that supply assets to airframe. And whether that's a tire or a brake or a wing or right, they're the OEMs providing that information. They're going to use Teamcenter to do that connectivity piece, but that's that data layer, and those individuals own the data. And I'll get to the glue of the value of that in a minute of the layer cake. And then you have a service mesh piece that has common services in it. Every single thing, especially when you start looking at cybersecurity, has to have an ATO attached to it, right? And how do we get after that so we aren't continually rebuilding, re-ATOing over and over again, is that you build common services. Common services that everything needs are very basic. They need identity. We need to know who is getting to things. We need to be able to log things. We need metrics off of them. Those are all basic services that you build in that layer. And then on top of that go your applications and where users are coming in at that Teamcenter piece that's coming into that layer cake. The value that stack provides is that ecosystem that we were referring to. And it looks really simple, right? It's a beautiful picture, but there are so many tools and so many capabilities, and us understanding how we want them to interoperate and work together is really, I mean, it's really a longer conversation. So I'm going to stop there, because I think we're probably going to expand on that. But
so you talked about all the different kinds of services that are out there. The scope of DMM, as General Richardson said, it's all functionals, it's all life cycle phases, and it's all domains. It spans a very large array of tool sets. We talked about Air Force PLM, but there's Launchpad out of the DPAS. There's PMRT. You've got the Big Six, flights, the KT file share for contracts, ConIT, AFAOC, FACS, SFIS, CADE, P1, C1s, Platform 1, Cloud 1's DevSecOps pipelines, the Microsoft 365 suite, and I didn't even get through everything that's listed on the digital guide. This is the panoply of digital tools that are out there. And a lot of these different groups are trying to solve the same kinds of problems. You have the ASDP effort, you have SFIS, S1000D, the model-based acquisition group, SAE and ISO standards. So I want to open this up. What is your perspective on data standardization as a process across all the different stakeholder groups? How do we come to a consensus on how we're going to standardize our data? Does it still run through kind of a formal AFI 6101 process? Or does it become more toolset specific as we have to get down to brass tacks of interoperability?
So, we've started Teamcenter in the configuration when we were on-prem on different sites, on the A10 and other programs. But one of the journeys we've been on is to move to the cloud. So Teamcenter is offered as SaaS. It's on Cloud One, part of the platform. But Teamcenter is really just the backbone of our whole accelerator portfolio. So there's a whole bunch of solutions, clients that do things like S1000D, that do things like a maintenance-aware design environment to look at how I build system models, how do I connect my system engineering tools. So that plays into that thing that we're delivering our software as services that can then be deployed to those. And now I can get those tools and connect them to the structure that's in the PLM system. So that's really the next step in what we call the accelerator portfolio, is bringing a bunch of tools, not just ours, but other people's tools, because we really are about open standards and working with OMG and SAE and ASTM. As a matter of fact, talking to the standards organizations about bringing the standards into the PLM system as objects and sort of lead to your PDF question, which I'll defer to later.
Any other comments?
No, I agree. I think that we have a mandated PLM system, and the next step is a enterprise level integrated digital environment, and how that's structured is going to take collaboration with everyone, right? To limit the amount of tool sets, so we don't have to force tool sets and prohibit innovation from our industry partners in academia.
Okay. And if there are any questions from the audience, feel free to raise your hand, grab a mic, and come ask whatever burning questions about structuring, securing data are on your mind. Yeah.
I just have one. No, I fell off. There. Okay. So I have just one, I guess, on the architecture layer part of that conversation, right? Where we talk about, I've talked about, like, we have suppliers. They're all connected to Team Center. They have proprietary information that they need to maintain, and we need to respect that. And we talk about the OODA loop cycle. Well, I guess we really don't call it an OODA loop cycle. We just say we need to we need to go faster, right? We need to accelerate faster, and we need access to data when we need it. We need to see it. And when we talk about that across the ecosystem, it is in a lab environment where I'm going to try and test things out before I transition it. But it's in those integration environments and those production environments as well, where if we are downrange and we're starting to see, I'm going to pick tires. We have tire wear happening on an airframe, and we want that to come back through the system so that it goes back to the OEM to say, hey, we're seeing tire wear, and we can give them a model that says this is what it looks like, and they can do a twin over the top of it and say, okay, well, this is the change that I need to. They can automate that change back to you and say, is this acceptable, and this is what your bill of materials is going to look like. And then we have the ability to then respond constantly through the cycle. And I think that's what we're talking about trying to do from the architecture layers all the way up through Team Center to the end of the airman that's standing on the airfield at a forward base to an engineer that's sitting in an office trying to say, hey, I think it would actually, maybe the aircraft would have better performance if we adjusted the edge of the wing. I don't know, I'm just making up scenarios.
Sort of the other side of that 11% of the data that's coming from the OEM. Now there's that still maybe 11% coming back to the OEM. And this is talking about being able to enable that two-way connection. And that sort of leads you to this whole element of trust. You know, in this, how do I trust who's what? We talk about zero trust all the time, but you want to get to the point in trust where the government understands the provenance. Who's touched what along the way to know it hasn't gotten in the wrong hands. And the OEM wants to know that that data doesn't go into the wild, that their intellectual property is respected, not just that it's taken by somebody else, but it's not abused by somebody who has rights to it. So you have to set up those rules of how do I establish trust, you know, both down and up, so that we can collaborate more efficiently.
I agree, and I think that's where those identity services come in. If we know that I am Samantha, and no matter which direction I come in, you can authenticate that I am the person that I say that I am. You can do multi-factor authentication on a couple different platforms to do that, right? To enable us to have security both from I need to protect my company's data, and I'm going to let you have access to only these fields, right? Attribute-based access to data in all of these different locations. That's going to give you so much more strength to say, if I actually, as an engineer, if I wanted to look at a different, if I did want to look at a different wing structure, right, I would be able to get access to that data at a click. And that's where we want to get to, right?
That's one of the exciting things now with all the things that, you know, everyone here, Microsoft Authenticator, Ping ID, Alight, your PKI card, there are a bunch of different ways to do that have emerged in the just short period of time. I have 4 authenticator apps, but it's just about, now those are standards, those can be connected to, and you can connect that system to validate who somebody is and give them the rights to do that. And it's one of the things that we do at Team Center is enforce those rights. So once I know that that person authenticated, then I could go about, the authorization of the data. What rights do they have with some trust that I know what's going on.
So going on the same kind of theme, what are other enabling services that are necessary to support the creation and use of standardized data? And, we talked about the security aspects, but what about when it comes to data rights, or how do we sustain this data over time? What other services come to mind when you're thinking about what does it take to really get down to structuring and securing the data?
Well, there are a couple different strategies for that. And one of the simplest ones is you don't have the data really leave the enclave. You bring the worker into the enclave, so it doesn't leave the place. So you can build secure enclaves where somebody can work wherever they are, but they're going to the cloud, inside of the firewall, and doing what they need. And the data doesn't come to their desktop. It stays right there, and you can audit it and know what goes on. And they still have access to it. And as long as you can get access to the tools in that environment, then you can enable that.
Yeah. I think I look at it from a couple different angles, right? So it depends on what I want to do. If I am doing testing and I want to experiment, I want to pull the data in. I potentially want to manipulate it. I want to understand how the data is getting to me, right? And what structure and what form it's in. And is that the right form? Or am I just accepting it because that's what they gave it to me? And is that going to be an iteration conversation of, okay, it would be easier, and actually I could automate this and I could integrate it with 3 other data sources if the format was pick it. And be able to bring it into a test environment where you could say, this is what I would like to change, and then iterate on that to create the change, and then pass that through. I talked a lot when I was at NASEC, I talked a lot about yellow brick roads, building the yellow brick road, because I felt like every time we asked somebody to transition, that tech transition was super hard. It was super fun, right? Super fun to do tech transition. But giving them a yellow brick road to say, if you want to move your code, if you want to move your data, if you want to move, this is the process. You drop it here, it does these scans, it goes here. And then you can provide automated testing. I'm not going to tell you we got to automated testing. I think they're still working on the automated side of it. Yeah, right. So if you give me a test plan, we can run the test plan. We know what the results are. Are they the same? If they're the same, it goes. If it doesn't, it can either roll back or you bring somebody else into that conversation. And you can do that with code. You can do that with data. You want to validate, right, that the data that I have is still, I still have the same integrity. You have a yellow brick road to build to get there, to say, what was my checksum? What did the data look like? Or better yet, when we do machine learning against maybe PDFs, right? We can OCR PDFs and we can pull data out of PDFs. And we can drop that into a data service if we want to. But those are 3 steps. Can we just do that on the fly with all of them? We can, I guess, my point. We can do that today. But when the machine rides through it, is what you were getting back, do you agree with it? Because the human has to understand it, and the human makes a lot of those calls. If it's looking for a pen, and it says that a pencil's a pen, and we're like, no, that's a pen, and you have to give it that OODA loop call back to say, now I want you to learn the differences between a pen and a pencil, right? We need to be able to have data at that point too, but understanding the data security as it comes across, either from an OEM, across environments. And when I say across environments, I also mean moving up into secure environments, into secret environments, into the TS environments. The process is very, very similar. Going up is much easier, obviously, than going down, but that process is very, very similar. You have to know what it looked like before it left, and when it gets to the other side, you have to be able to validate and verify that nothing changed from when it started to where it ended. And then there's a whole workflow that can go along with that, and workflow services are part of that.
Many workflows that go that, because that example that you had of getting feedback from the field about a tire, and that comes in, and you do a trade study on that, that becomes part of your digital twin. But you're looking at that from the product support perspective, but that is really looking at the outcome and the decisions the product support manager has to make, but it's also going to impact the decisions that the designer is going to make and his perspective of the digital twin, and what the manufacturers may have to do with that, and what the test engineers have to do. And that data will get reused if you keep it connected. And you can reuse, and what is of value to you may even be a different value to somebody else. And that's one of the challenges with the PDF, is that it gets contained in a set for one value. It's really designed for a specific target. You want to be able to take the knowledge out of that, put it in the graph, so that multiple people can use it for different purposes. Still have it be, a standard, a spec. But now, if I can address it independently, I can reuse that data and use that knowledge to build the digital twin.
So, PDF turned 30 years old just earlier this summer. So it's been a staple of this industry, because even if I got a PDF from 1993, I can still open it today. I can't do that with a Word document from 2003, all right? Because I'm not allowed to open .doc files anymore. So how do we get to the same kind of data portability and sustainability over time from a standard perspective? Because a concern that I frequently hear is, okay, so I built a model in Cameo 19. Am I still going to be able to read it in Cameo 25 when my system actually goes into production? Is it still going to be useful when we get to, when the Air Force, for whatever reason, goes away from Dassault and goes to a completely different product? Am I going to have the data portability? Because you know what I can still open? I can still open a PDF. So how do we get to that kind of data standard portability over time when we're sustaining aircraft for 20, 30, 50 years?
There's been other types of data. 30 years ago, as part of my MIS, I wrote a paper looking at PDF and SGML as ways of doing that. And the beauty of SGML was that I could reuse it, repurpose it, and do that. The beauty of PDF was there's a content creator. I could lock it down for the one purpose I want. You couldn't move it around, and I know that it was used in the way I wanted to. Now we've gotten to the point where SGML has evolved to HTML, to XML, to UML, and these different models. And you can still do that. There are transforms. As long as you tag the data correctly and build the schema and publish it as a standard, there's ways to move from SGML to HTML to XML. And that allows you to take the data at the atomic level, which is of more value to more people. And that's been around. It's just, the PDF is a nice container, looks, but it's hard to use. It really is. And so, SAE, OMG, they're all looking at, how do I democratize standards? They're expensive. You get them, but not everyone has them. But if they become part of the twin and everyone can use them, they're going to change the way that it's delivered.
Well, and I feel like where PDFs are concerned, we have to decide, let's be honest, we do a lot of PDF work still. And so some of it's accepting where we are today to how do I get to the next step, and knowing that I do have the capability to pull the data out of the PDF. I can store it in a bunch of different data services, but also run it through a workflow of some sort to say, is the data standardized? Because we as humans do not always standardize, or ever, maybe feels like some days, standardize our data. And making sure that we can then, as we do that, I'm going to take it out of the PDF. I'm going to accept it from you as a PDF today, because that's where we are, right? Accept where you are. And then I'm going to standardize it as I get it into a service. And then at that same time, tag it at the attribute level to allow access to users by who they are, by their persona, and by why they need what pieces of data. And that gives you the ability to then control, I'm not going to give you two pieces of data that, I'm forgetting the term, I've been out of Intel for 3 months, that increases the classification of that data piece.
That's one of the things PLM does, is being able to keep these connections together, because most of things aren't written in PDF. They're written in Word, or they're written in S1000D, and then published to PDF, so that the designer could lock down the content they wanted to. But there's no reason that you couldn't keep that S1000D structure that the authors put it in, publish it to PDF so that people who needed to see it in context, and make it into an XML structure that would be a requirement structure that you could address, and have them all be related. And it depends on who you are as to how you're going to see the data. If you want to read this thing 30 years and see it the way it was intended, that's it. But if you want to use it, it's the same item. It's managed the same place inside of your PLM system. And being able to look at that from the creator, the consumer, and the reuser of the data, and have it all be at one place.
That work is currently being done in AFPLM with requirements management module, looking at taking legacy PDF specifications and breaking them down into individual requirements so they can be linked and tied and traced within the PLM environment.
You still keep the PDF, it's a cover page now.
So we're talking about taking the data and rendering it in many different forms for many different purposes. What are your thoughts on how we can effectively govern the authoritative source of truth, not just between primes and the government, but over the life cycle? There's data we buy at the front end that isn't used until it gets to the sustainment portion of the life cycle. You might be deep in depot sustainment for years before you start looking at data on a particular part that wasn't going to fail inside of the normal 20-year lifespan of the aircraft, but now we're at 35 years. So how do we structure the governance of data so that we can do that configuration management across organizations and preserve it as a definitive source that everyone knows where the data came from and what it's built on? How do we contract for that? How do we allocate that responsibility? And when? Sure.
Yeah, so I've been in the Pentagon talking about technical data as a service. What would that mean? Because you have to maintain the digital twin just like you have to maintain the asset. There's same kind of things you have to do, configuration management, change control, access, all that stuff, it requires some time. And while you have an OEM who's still working, he's already doing that. He's doing that for their platform. And so it makes sense for them to continue to do that and deliver to you. But at some point in time, you want to say, okay, I might need this data 20 years down the road. How do you do that? So we talked about building technical data as a service, so you sort of contract up front for options of the data, and you understand that your tech manuals are going to be pretty cheap, but the secret sauce for how you built your intellectual property might be a little bit more expensive, but then you could pay the OEM to maintain it until such point that you took ownership of that package. And when is that? Is that at full rate production decision? Is it at initial capabilities? Those are all things that we have to think about from a contractor point of view.
Yeah, I think the only thing I have to, I haven't been in this space very long, but the challenges we had at NASIC, and they're still working through those, right, is what's the life cycle of the data? What data do we need to make a decision? What data do we bring together to actually build a product? It seems like we would know that, and to be honest with you, we sort of did, or certain individuals did, but we didn't really understand it, the life cycle from end to end. And I talked a lot about data characterization at NASIC, where I was like, okay, so there's a couple, and I'm going to try not to spin this out of control. It's going to be hard for me. But where we talked about, one was, when we produce a product, what do we need? We get bunches of sources of data that comes in. Do we keep the source? Well, we're told to keep the source. I'm going to be honest. By law, we have to keep the source. But how long do you keep the source? How long does your customer need it? And at what point through that production cycle do you need that source data? Because when the source data comes in, you have a workflow, whether that is an automated workflow, which is where we would like to be, right? Where we run algorithms against it and it matures the data over time. But then we might realize in a year that we're like, well, you know, I could have run a different set of algorithms against that, or maybe these algorithms are newer, and I might get more fidelity. And so I'm going to rerun that again against that same piece of data, but I want to keep both of those. How long do we keep those? That's a hard question. It seems like it would be like, well, I'm just going to throw that first one away, right? But if you actually publish against it, in an Intel world, if you publish against a report, you have to hold on to it. But how long? Also a good question, right? And so we put like blockers on it. And when I ask the question of why and how long, I ask the question of why and how long because sustainment lives and dies by how much do I have to hold on to? How long do I have to hold on to it? Who owns the data? Back to that governance side, right? Because when you get into some places, and it actually gets a little messier, I think. I made this statement yesterday when we kind of talked to the team. There's some things inside the Intel space that's harder and some things that are easier. And I feel like governance of data and ownership of data on the unclassed side, it's harder because there's a lot more owners of the data than there is.
Very distributed.
It is very, very distributed, yes. And trying to figure out the question of, in Samantha's perfect world, right, I would want those OEMs to own their pieces of the data, and I would want to be able to pick them up when I need them and do the things that I need to do with them. And they are the authoritative sources of truth. And if I know unilaterally that I can always go and pick up that data, then I would be less likely to do the part where I'm like, well, I have to hold on to the data. Now, we have analysts and engineers, and I'm the same way, so I'm just poking at myself, I guess, that, I want to have a piece of that data because what happens if I manipulate it and something changes, then I don't understand what that delta change is, and it can cause some change in my process that I don't have any control over. But understanding that life cycle of how long do I need the data? My data, after I've manipulated, is no longer the original authoritative source of truth, and accepting that and documenting that so you understand whether it's a product that you're producing, whether it's an engineering diagram, whether it's a test plan, what does that mean? Because it means different things depending on where you're at in the maturity cycle.
Yeah, so the whole purpose of a digital thread, sort of digital twin, changes over time. I mean, early on, you build the digital twin to make decisions. And really, if you could lay out all the decisions you need to make, you could determine what the digital twin, as it goes down, the digital twin is really delivered by outcomes, all right, in the operational field. So what are those outcomes I expect? And where does it transition from decisions to outcomes? And that determines where you invest in the digital twin. And that's where digital threads come in because everybody has a different perspective. The production guy has a different perspective than the test guy who has a different perspective than the contracting officer. But if they're all contributing to that, and we understand those decisions up front, it helps define what really needs to be managed in your PLM system.
So we've talked a lot in this conversation about structuring and securing data, but that isn't, structuring and securing it is a cost. What are the benefits that having structured data unlocks for digital material management, for our ability to be agile or adaptable to change, like General Richardson was talking about? Like, the goal is adaptability and change resilience. What else does structuring and securing our data unlock in that space?
I think a big benefit to structuring the data is the waste that we'll eliminate. Right now, with the legacy DIDs, every function is buying their data a specific format or way to suit their needs. And a big one comes with engineering and sustainment. When it comes to those large data packages, a lot of times you're purchasing a engineering technical data package, and then logistics is also buying a sustainment data package. Well, if you look at that data behind the scenes, it's the same pieces of data, just organized a little different. So it's one of the tasks for the ASDP initiative is to look at all of those pieces of data that we currently believe we need to produce, sustain, maintain, operate, and modify the weapon system, look at how we are purchasing them today, and how bringing them into that digital model-based definition, we could eliminate the need for a lot of that repetitive data delivery.
And we could also revolutionize the supply chain. Because basically, if you have a digital twin of the product, a digital twin of production, you can start going and moving to digital inventories rather than physical inventories. Change the way I'm going to do it so that I can compensate the IP providers for their IP, but then deliver manufacturing through flexible manufacturing that are closer to the point of need. So there's a bunch of projects going on now about making parts on chips or in the field, or how do I do it closer to that? And looking at, even in commercial, being able to separate the intellectual property owners from flexible manufacturing so that I don't carry all the warehousing, all the packaging, all the transportation costs, that I can actually move to a digital inventory that I can make close to the point of need. And there's a huge cost savings there.
Anything to add?
I have nothing to add because she wants us to leave.
Well, thank you very much to our panelists.
All right, everybody. Couple of announcements. Thank you so much to our panel again for being up here. Appreciate it. Another little quick round of applause for them. And I have a couple of announcements that I want to make just really quickly as we're rolling into lunch. So if you parked in the Rybold garage, which is right there on the corner of 5th and Main Street, I just wanted to repeat again what I said this morning. No need for any type of validation. You can get in and out of that garage. Those gates should be open. So if you need to leave, come back for any reason, or at the end of the day when you leave, just roll right on out of the Rybold garage. Okay. And then lunch will be served right here where you're sitting. So we have a plated lunch for you. If you have your name badge, take a look at that, and you should have a little star on there. You picked this morning whether you were going to have chicken, prime rib, or maybe a vegetarian meal. The color of that star sticker is going to help you out with which meal is going to be delivered right there to your seat. Silver's chicken, and the red is the prime rib. So have that kind of out and visible, and that will help our servers get your meal to the correct seat there. And lastly, again, I know I've been mentioning a lot of our great WITS sponsors who are supporting this event, and we're so thankful to have their support. Our presenting sponsor this year, and they've been with us for the last few years, and we really, really appreciate their support, is MFGS. And they have been, oh, all right. Yeah, I like that. We'll take all the applause. So thank you to MFGS for being our presenting sponsor this year. And as we roll into lunch, I'm going to play a video from MFGS. So pay attention to the screens here as we're getting into lunch. And the time that we're going to plan to be back from lunch, we're going to go with what's on your program. Pretty close to it, 13:45. So thank y'all.
Analytics system, our customers are addressing the 4 core pillars of digital transformation. Our mission is to provide your agency the ability to bridge the existing and emerging technologies, allowing you to move faster, have greater agility, secure what matters most, and surface critical insights, all while removing the need to take a risky rip and replace approach, so you can run and transform at the same time. At Micro Focus, we call that smart digital transformation. For more information on how MFGS Inc. can help